Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about properties of molecular substances. So molecular substances are made up of small molecules that are the molecules themselves are held together with really strong covalent bonds, but between the molecules there's weak intermolecular forces holding the solid or liquid together. So the covalently compounds are small and use covalent bonds. And covalent bonds are the ones where they share electrons. So molecular substances have low melting points. They're solids, liquids, or gases at room temperature. They have small finite structures. And though polymers also fall into this category, polymers are really long chain molecules. They can be very reactive due to the size and combination of nonmetals. They're normally soft and brittle when solid, but they are volatile. That means they easily evaporate. So iodine actually evaporates straight from a solid to a gas at room temperature. Okay, so if you've got some iodine, purple iodine crystals, they are so volatile that you don't need much energy to change them into a gas. So that's called sublimation, remember? Okay, so this video is about how the molecular structure, how the structure of and the bonding of the particles affects the physical properties. So the first physical property we're going to think about is solubility. So in this picture, we've got molecules of water, and then we've got molecules of methanol. Okay, methanol is the first in the series of alcohol molecules. And methanol is very soluble. Uh, that's because there are interactions between the solvent molecules and the solute molecules, the methanol. And that means that the water molecules can pull apart the liquid and surround the methanol molecules. So to dissolve, there must be an attraction between the solvent and the solute, the thing being dissolved. In most cases, we're talking about water, okay? But just be careful, you might get questions where it's the solvent is something else. When molecular substances dissolve, the molecules themselves stay bonded together. That means the strong covalent bonds holding the molecule together don't break. So there's really strong covalent bonds holding the methanol together. So it's not going to break. But what happens when it dissolves? But the molecules themselves are separated from each other. Okay, so when something dissolves, these weak intermolecular forces between the molecules, inter means between, like intermediate, between primary school and high school, between the molecules, intermolecular forces. So the molecules that have these temporary or permanent attractions to the water molecules will dissolve. Some molecules are polar. Now, methanol is polar, and we're going to talk about polarity in a later video. But water is a polar substance, so that is more likely, so just remember that there's more likely to be attraction between two polar molecules, and so that there's a stronger attraction and they're going to be more soluble. This is a really cool picture that shows a piece of salt. So when we talked about ionic compounds, salt, sodium, chloride, we've got positive ions and negative ions. And what happens is that the water molecules surround the ions. So that's just a review of an earlier video where we talked about how ionic compounds dissolve. The similar thing happens with molecular compounds, but the molecular compounds stay together as molecules. So the water still surrounds these molecules, but there's no charge on them. Okay, they're still neutral molecules. So the molecules stay together. All right, I think this is a picture of the molecule. Maybe this is a sugar. Uh, this is a sugar molecule. So we'll just see that a bit clearer. For example, glucose or sucrose, and the sugar stays together, all right, when it dissolves. For example, this is an exam question. Bromine is soluble in water. Justify the statement in terms of the particle structure and bonding for the substance. So you need to state that it's a molecular substance that's made out of molecules and that there are weak intermolecular forces holding the molecules together. The attraction of the water molecules is sufficient to separate the bromine molecules, meaning bromine is soluble in water. Another example, iodine doesn't dissolve in water, but it does dissolve in cyclohexane. Now, cyclohexane is an oily kind of non-polar solvent, sorry. So state the obvious again, state it's a molecular substance made of molecules. There are weak intermolecular forces holding the molecules together. To dissolve, there must be an attraction between the solvent molecules and the iodine molecules. Iodine molecules are non-polar, therefore iodine is soluble in non-polar solvents such as cyclohexane. They both have similar weak intermolecular forces, and those weak forces will exist between the two different molecules. So the attraction between polar water molecules and non-polar iodine molecules is not enough to overcome the attractive forces. So it won't dissolve in water. The attraction is not strong enough. It does dissolve in non-polar things because there's attraction between the solvent and the solute and the thing being dissolved. Okay, let's move on. So when something goes from a solid to a liquid, we say that's melting, or liquid to a gas, that is evaporating or boiling. So the temperature that it does this indicates how much energy needs to be added. So when you have a solid, the molecules are all lined up in the solid, but they can't move past each other. In a liquid, the molecules can move past each other. In a gas, they're fully separated. All right. So in the liquid, they're a little bit separated. So between these molecules is intermolecular forces, and they're pretty weak. So they're weak, and so there is only a small amount of energy is needed to overcome the attractive forces. So the molecular substances have slow melting and boiling point. So that's a temperature that things melt or boil. And so you might get a question about that. Bromine has a low melting point. You need to, again, so that's a molecular substance made of molecules. There's weak intermolecular forces between the molecules. Forces of attraction between neighboring bromine molecules in a solid are weak. So therefore, only a small amount of energy is needed or required to separate the bromine molecules from each other. So bromine has a low melting point. Remember, when you're giving the reasons, there's so, therefore, and so, these linking words are really important. They'll be looking for those in the exams. Okay, these molecules, they don't conduct electricity, because to conduct electricity, you need free or mobile charged particles. That's either electrons or ions. And in this case, all the electrons are held in these covalent bonds, so they can't move around, so that they will not conduct electricity. So you just need to say it does not contain mobile charged particles, no free electrons or mobile ions. Therefore, remember these linking words. Therefore, sulfur cannot conduct electricity. Now, sulfur is S8, so its molecules, it's got 8 sulfur, but you actually don't need to remember that. You just need to remember that sulfur is a molecular substance. Okay, so this video has been how to explain the solubility, which another word for that is miscibility of molecular substances, the relatively low melting and boiling points, and the fact that molecular substances do not conduct electricity.